You're designing a map of a town. In this town, 3 streets, Bridge Street, Cloud Street, and Otter Street, form a triangle. Their lengths are shown below. So Bridge Street is 7.2 miles, Cloud Street is 5.1 miles, and Otter Street is 5.6 miles. To create a map that is drawn to scale, you need to know the angle formed at the intersection of Bridge Street and Otter Street. What is this angle? Now let's examine the information we've been given. We've been given 3 side lengths, but no angles of the triangle. So in a case like this, we can use the law of cosines. So recall that the law of cosines tells us that when big A, big B, and big C are angles of a triangle, and little a, little b, and little c are the sides opposite those angles respectively, then the following 3 equations hold true. So before we can figure out which of these 3 equations to use, we need to label our triangle. Now, it doesn't really matter where we put big A, big B, and big C, as long as we put the lowercase letters on the sides opposite each of those angles and choose the appropriate formula depending upon which angle we're solving for. So let's go ahead and label the diagram. So you'll notice that I labeled my triangle so that big A is the intersection of Cloud Street and Bridge Street. Big B is the intersection of Cloud Street and Otter Street. And big C is the intersection of Bridge Street and Otter Street. I've also labeled each side according to which angle it's across from. So you'll notice that little a, or the 5.6 miles, is across from big A. Little b, which is the 7.2 miles, is across from big B. And little c, which is the 5.1 miles, is across from big C. So remember that we're trying to find the angle at C, which is the intersection of Bridge Street and Otter Street. So because we're trying to find angle C, we need to use the formula that has angle C in it. And of course, this is formula number 3 right here. So we're just going to plug in the values that we have, and we have little a, little b, and little c, into that formula. So we have that 5.1 squared equals 5.6 squared plus 7.2 squared minus, in parentheses, 2 times the 5.6 times the 7.2 times the cosine of c. And now we want to get the cosine of c by itself. So simplifying, when we simplify 5.1 squared, we get 26.01. And then when we do 5.6 squared plus 7.2 squared, we get 83.2. And when we do 2 times 5.6 times 7.2, we get 80.64, so I just brought that down. And then just bring down the cosine of c and keep that in parentheses for the time being. So now, because we want to get the term with the cosine of c by itself, our next order of business is to subtract 83.2 from both sides. And when we do that, we're going to end up with negative 57.19 equals negative 80.64 times the cosine of c. So when we divide both sides by negative 80.64, we get the cosine of c by itself, and we see that the cosine of c is equal to 0.71. So in order to figure out the angle at c, well, first we want to make sure our calculator is in degree mode so we get back the correct answer. Once we do that, we're going to take the inverse cosine, or the arc cosine, of 0.71. So it should look like this, and when you do that, you should get back the measure of angle C, which is 44.8 degrees. So therefore, if you're drawing a map, the angle you should use to draw the intersection of Bridge Street and Otter Street is 44.8 degrees.